Lesson 3.8 covers the inverse of a matrix. Suppose we were solving the following equation, but we were told we could not use division. So if I had 2x equals 30, well, normally we would solve for the x by dividing each side by 2, but this problem told us we could not use division. So if we were not allowed to divide, the other option is to multiply each side of the equation by the reciprocal or the multiplicative inverse of 2. The reciprocal of 2 is 1/2. So if I multiply each side by 1/2, 1/2 times 2 gives me 1. So I end up with 1x, or just x, and 1/2 times 30 is 15. So I still get the x equals 15 that I would have got if I divided each side by 2. Using the inverse of 2 worked because when we multiply a number by its inverse, the result is a 1. Well, in this lesson, we're going to see these same principles applied to matrices. So let's look at this example. I want to multiply the following matrices. I have the matrix 3, 8, 2, 4 times the matrix 1, 2 times the matrix -1, 2, 1/2, -3/4. Well, these are each 2 by 2s, so the number of columns in my first matrix is the same as the number of rows in my second matrix, so I can multiply these. So I'm going to multiply each row in the first matrix by each column in the second matrix. So I have row 1 times column 1, row 1 times column 2, and then row 2 times column 1 and column 2. Well, row 1 is a 3, 8, and column 1 is a -1, 1/2. This gives me -3 plus 4, which is 1. Row 1 was the 3, 8, and this time times column 2 is 2, -3/4. Well, 3 times 2 is 6, and 8 times -3/4 is a -6, so this gives me a 0. Now row 2 is 2, 4. Column 1 is -1, 1/2, so this gives me -2 plus 2, which is a 0. And finally, row 2 is 2, 4, and column 2 is 2, -3/4. So 2 times 2 is 4, 4 times -3/4 is -3, and 4 minus 3 gives me 1. So if I put these answers back in a matrix, in row 1, column 1, I have a 1. In row 1, column 2, I have a 0. In row 2, column 1, I have a 0. And in row 2, column 2, I have a 1. Well, if you notice that the answer was the identity matrix for a 2 by 2 matrix. If the product of two matrices is the identity matrix, then the two matrices are inverses. Just like with the two numbers, 1/2 times 2 gave me the identity element of 1, so 1/2 and 2 were inverses. They were multiplicative inverses. Well, if I multiply two matrices and I get the identity matrix, those two matrices were inverses. Well, let's look at finding the inverse of a matrix. There are several ways to find the inverse of a matrix. The method that we're going to use in this class is to use the elementary row operations. Even though there's several ways to find the inverse of a matrix, I want to use the row operations because we're going to use these again in the next unit, and I want you to become very strong with them. This method will only work for square matrices. And in this class, we're going to just focus on the 2 by 2 matrices. Well, the steps First, you're going to form an augmented matrix AI, where A is the original matrix and I is the identity matrix. Then we're going to use the row operations to change matrix A to the identity matrix, just like we did with Gauss-Jordan elimination. Once we change the first matrix to the identity, the second matrix becomes the inverse. So the result is IA inverse, where A inverse is the inverse for matrix A. So let's look at some examples. I want to find the inverse for the following matrices. So I have the matrix 4, 8, 2, 6. So the first step, this is a 2 by 2, and all of the matrices for this class we're going to use 2 by 2s. I begin by writing my given matrix, the 4, 8, 2, 6. Then I draw my equal bar and I put the 2 by 2 identity. Now I want to make this first matrix become my identity. So I want to change the 4 to a 1. There's not a 1 below it, so I'm going to go ahead and just divide this first row by a 4. If I divide row 1 by 4, I get 1, 2, 1/4, 0. And remember to use fractions instead of decimals in these. So this is going to become my new row 1 and keep row 2 the same. Now that I have my 1 in place, I want the 2 to become a 0. So change its sign to a -2 and multiply by the 1 that's in row 1. So I'm going to have -2 times row 1. -2 times row 1 gives me -2, -4, -1/2, and 0. I'm going to add this to the row I want to change, which is row 2. Row 2 is 2, 6, 0, 1. This is going to give me my new row 2. -2 plus 2 is 0. -4 plus 6 is 2. -1/2 plus 0 is -1/2. And 0 plus 1 is 1. So rewrite row 2 and keep row 1 the same. Next, I move to column 2. I want this second digit to be a 1. So I'm going to divide row 2 by 2. If I divide row 2 by 2, 0 divided by 2 is 0. 2 divided by 2 is 1. -1/2 divided by 2 is -1/4. 1 divided by 2 is 1/2. So this becomes my new row 2, and you keep row 1 the same. Now finally, I need to make the 2 become a 0. So change its sign to a -2. I multiply by the 1 that's in row 2. So -2 times row 2 gives me 0, -2, 1/2, -1. I add this to the row I want to change, which is row 1. Row 1 was 1, 2, 1/4, 0. This is going to give me my new row 1. Well, 0 plus 1 is 1. -2 plus 2 gives me the 0 that I wanted. 1/2 plus 1/4 is 3/4. And -1 plus 0 is -1. And I do encourage you to use your calculator for the fractions. So now my new row 1 is 1, 0, 3/4, -1. And row 2 stays 0, 1, -1/4, 1/2. Now that my first matrix is the identity matrix, the second matrix is my inverse. Don't leave this augmented matrix as your answer. The inverse is just the second half. So the inverse is the matrix 3/4, -1 for row 1, and row 2 is -1/4, 1/2. If you wanted to check to see if you had the inverse correct, you could multiply this by the original matrix and you would get the identity as your result. Well, let's look at the next example. I have the matrix 3, 8, 2, 4. So I'm going to begin by writing this as an augmented matrix, and I'm going to put the identity matrix on the second side. So row 1 is 3, 8, 1, 0, and row 2 is 2, 4, 0, 1. Now I want my first matrix to become the identity matrix. So I need that 3 to become a 1. Now I could get the 3 to become a 1 by dividing everything by 3. But that would give me a fraction for my 8 and a fraction right here with my 1. If you notice, if I had the 2 first and I divided by 2's, the 4 divided by 2 would give me a 2. I would only have a fraction here. So you don't have to do this step, but I'm going to let step 1 be to switch rows 1 and 2. By switching those rows, I'm just getting fewer fractions. So if I switch rows 1 and 2, row 1 becomes 2, 4, 0, 1. Be sure to switch the identity as well. Row 2 becomes 3, 8, 1, 0. Now to get the 1, I'm going to divide row 1 by 2. And as I said before, you did not have to switch these rows. You could work this problem by dividing row 1 by 3. You would just have more fractions. If I divide row 1 by 2, I get 1, 2, 0, 1/2. This is going to become my new row 1. And row 2 is going to stay the same. Now that I have my 1 in place, I want my 3 to become a 0. So change its sign to a -3 and multiply it by row 1 because that contains the 1. Well, -3 times row 1 is -3, -6, 0, -3/2. Add this to the row you want changed, which is row 2. Row 2 is 3, 8, 1, 0. This is going to become my new row 2. Well, the -3 plus 3 gives me the 0 that I wanted. -6 plus 8 is 2. 0 plus 1 is 1. And -3/2 plus 0 is -3/2. So keep row 1 the same and replace row 2 with 0, 2, 1, -3/2. Now that I've finished column 1, I move on to column 2. I want this first 2 to become a 1, so I'm going to divide row 2 by 2. When I divide by 2, I get 0, 1, 1/2, -3/4. So this becomes my new row 2, and keep row 1 the same. Now for my final step, I want this 2 to become a 0. So change its sign to a -2, And this time I'm multiplying by row 2 because that contains the 1. So negative 2 times row 2 gives me 0, negative 2, negative 1, 3/2. Add the row you want changed, which is row 1. Row 1 was 1, 2, 0, 1/2. This is going to become my new row 1. Well, 0 plus 1 is 1. Negative 2 plus 2 is the 0 that I wanted. Negative 1 plus 0 is negative 1. And 3/2 plus 1/2 is 2. So row 1 is 1, 0, negative 1, 2, and keep row 2 the same. Since my left-hand side is now the identity matrix, my right-hand side of the equal bar is the inverse. So my inverse is negative 1, 2, 1/2, negative 3/4. Let's look at the next example. I have 2, 1, 0, 1. And I want to find this inverse. So I begin by making an augmented matrix. Your original matrix goes before the equal bar, and your identity matrix comes after the equal bar. I want to make my left-hand side become the identity matrix. So look at the first column. I need this 2 to become a 1. There's not a 1 below it, so to make this 2 become a 1, I'm going to divide row 1 by 2. When I divide row 1 by 2, I get 1, 1/2, 1/2, 0. This is going to become my new row 1. Now my next step would be to put the 0 in place, and I already have a 0. So column 1 is complete. I move on to column 2. I have the 1 in place already, so my final step is to make this 1/2 become a 0. So change its sign to a negative 1/2, and I'm going to multiply by row 2 because that contains the 1 in that column. Negative 1/2 times row 2 is 0, negative 1/2, 0, negative 1/2. I want to change row 1, so I'm going to add row 1, which is 1, 1/2, 1/2, 0. This is going to give me my new row 1. Well, 0 plus 1 is 1. The negative 1/2 plus 1/2 gives me the 0 that I wanted. 0 plus 1/2 is 1/2, and negative 1/2 plus 0 is negative 1/2. So rewrite row 1 as 1, 0, 1/2, negative 1/2, and keep row 2 the same, 0, 1, 0, 1. Now that my left-hand side is the identity matrix, the right-hand side is my inverse. So my inverse is 1/2, negative 1/2, 0, 1. For the next example, I have the matrix 4, 2, 3, 1. So begin by writing it as an augmented matrix where you put your original matrix 4, 2, 3, 1 before the equal bar, and you put your identity matrix after the equal bar. Now I need my left-hand side to become the identity. So I want to get my 1 and then my 0. To make this 4 become a 1, I would have to divide this row by 4. When I do that, I'm going to get a fraction twice. Well, look at your second row. It's a 3. I would end up dividing this row by 3, and I would still get 2 fractions. So switching the rows doesn't give me fewer fractions, so I'm going to leave it as it is. So I'm going to divide row 1 by 4. When I do this, I get 1, 1/2, 1/4, 0. This is going to become my new row 1, and row 2 is going to stay the same. So now I want to change my 3 to a 0. So change its sign to a -3 and multiply by row 1 because that's where my 1 is. Well, -3 times row 1 gives me -3, -3/2, -3/4, and 0. I want to change row 2, so I'm going to add row 2. Row 2 is 3, 1, 0, 1. This is going to give me my new row 2. -3 plus 3 gives me the 0 that I wanted. -3/2 plus 1 is -1/2. -3/4 plus 0 is -3/4. And 0 plus 1 is 1. So replace row 2 and keep row 1 the same. Now that I have column 1 as I want it, I move on to column 2. I need the -1/2 to become a 1. So I'm going to divide row 2 by -1/2. And again, I encourage you to use your calculator for these fractions. Always give the answers as improper fractions. Don't give mixed numbers and don't give decimals. So 0 divided by -1/2 is 0. -1/2 divided by -1/2 is 1. -3/4 divided by -1/2 gives me 3/2. And 1 divided by -1/2 gives me -2. So this is going to become my new row 2. So I'm going to replace row 2 with 0, 1, 3/2, -2, and keep row 1 the same. Row 1 is going to stay 1, 1/2, 1/4, 0. Now for my final step, I need the 1/2 to become a 0. So change its sign to a -1/2, and I'm going to multiply by row 2 because that has the diagonal 1. So -1/2 times row 2 gives me 0, -1/2, -3/4, +1. I'm going to add this to row 1 because row 1 is what I want changed. Row 1 is 1, 1/2, 1/4, 0. This is going to become my new row 1. 0 plus 1 is 1. -1/2 plus 1/2 gives me the 0 that I wanted. -3/4 plus 1/4 gives me -1/2. And 1 plus 0 is 1. So row 1 becomes 1, 0, -1/2, 1. And row 2 stays 0, 1, 3/2, -2. Now that I have my identity matrix on the left, the matrix on the right is my inverse. So my inverse matrix is -1/2, 1, 3/2, -2.